Hello and welcome. In my previous video, I explained the theory behind regularization and the difference between L1 and L2 penalties. In this example, I'm going to demonstrate those concepts in Python by comparing three models: standard linear regression, ridge regression, and lasso regression. The goal of this walkthrough is to observe how regularization changes the model coefficients and how that impacts the model's performance. In the first cell, I'm going to import the libraries needed for demonstration. First, we'll begin by importing our libraries. Then we'll begin by loading in the dataset. We're fetching this dataset from scikit-learn datasets. Right? Then going to preview our first 5 rows just to see kind of the data that we're looking at. Make sure that our data types are as expected. Now we're going to look at our target variable. So we're just going to print out our target, our y-axis with our first 5 records. Now we're going to go ahead and perform our train test split with 80% going towards the training data and 20% going towards the test data. Now we're going to go forward with scaling our data. So it's important that we follow this step. As you can see my note here. To make sure that our values are on a similar scale. Now we're going to begin by initializing the models. So we're going to initialize our linear regression model, our ridge regression, our lasso regression. Then we're going to fit our models to our training data, so our X train, our Y train. Then we're going to predict against our X test data. We're going to go ahead and run that. And then we are going to go ahead and evaluate. So we're going to see a comparison of all 3 for the root mean squared error. So you can see here for our lasso regression, we scored actually the best, so at 82%, with both our ridge regression and our linear regression being at 74%. Now let's go ahead and view our coefficients. We can run that. And we see that with lasso regression, as we discussed in the previous video, lasso regression will take features down to all the way to 0. And so we can see we had 1, 2, 3, 4, 5 values get taken down all the way to 0 for their coefficients. And for ridge, we actually will have values taken towards 0, but not all the way to 0. So you can see this one, for instance, at 0.002282. That's just one example. Another is this one down to 0.040833. Now let's go ahead and look at this in comparison one from another. And we can see for each of our features, so for our med inc, our lasso performs with a lower coefficient than our other 2. You can see our house age with a coefficient that's lower than the other 2. And then for average rooms, we actually don't see our lasso. And that's because that got brought all the way down to 0 as a coefficient, so it's actually gone. It's not needed to be viewed. Now let's look at our absolute coefficient magnitudes. So this is if everything was scaled from 0. So our average rooms, for example, this was flipped on its head, and we took these as absolute values for both average rooms, latitude, and longitude. Right. So go ahead and run that there. And we can see what that looks like. So we see again, lasso is showing for 3 of our features for med inc, house age, and latitude. Now let's say I wanted to see, okay, exactly how many features. Say we have thousands of features, hundreds of features, etc. And we want to see how many features truly got removed. We can run this here, run our lasso model, and then say our coefficients, and then just say we want to see how many of them are equal to exact 0. Right? And we'll just run that. We know the answer is 5, but with a larger scale, this can be seen of how many features got dropped. So we can see that lasso is useful in cases where we're looking for a most accurate model or best performance model. and ridge is helpful in the case that we don't want to actually drop any features. We want to see what's the performance of each feature without dropping any. Right? So with that said, this is a great form of preventing the overfitting concept. And with that said, that will conclude this video. Thank you for joining me.